Assalamu alaikum. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilma. How are you all? Hope everyone is well. Hope everyone is enjoying the life, studying. Okay, now today we are going to learn a very important concept, that is two's complement. But before I move on to the topic, let me ask you a question. You must have heard about the term sign. Sign means what comes to your mind? A plus or a negative, a plus or a minus sign. Perfect. Which we call as positive or a negative number. Now, have you ever heard the term unsigned before? Never, because in reality, as we study in math, we only talk about the positive values and the negative values. We rarely talk about the terms unsigned, but in a computer, these two are handled completely differently. If I talk about the terms unsigned, which we have been doing till now, it means it is going to talk about a variable that can hold only the positive numbers. And positive numbers means all the values which are above 0. On the contrary, if I say I'm talking about the term signed, here I mean that the value can be a negative value as well as a positive value. And remember, the moment I say I am working on a signed value, then definitely the capacity of your byte or the amount of data that can be stored in a byte is going to change. So this is what we will talk about, handling the positive values, handling the negative values. So they are handled a little bit differently by the computer, and this is the topic for us today. By the way, I hope that you all have worked on left shift, right shift, as well as addition of binary and all the binary topics that we have learned, conversion topics. Any questions regarding any of the topic? None. Okay, now, if there is anything that you need, then at the videos are available for all these topics, like the addition of binary numbers is there. Similarly, the logical binary shift is there. So you can refer to it for your own learning, for your own revision. And I hope that, inshallah, it will help you people a lot. Okay, are we ready for this very important concept of handling the signed value? And this is done through two's complement. Now, what happens if I am given a signed number? This is my major concern. Whenever we are given a signed value, what we do is we are going to treat our most significant bit. If you remember, most significant bit was your extreme left value. It will be storing the data. It will not be storing the data as such. It will be now used to store the value 1 in case your number is a negative number. And the same MSB is now going to hold the value 0 in case the number is a positive number. I hope that I'm very much clear. And definitely with this, what happens is the capacity of your, you can say byte will also change. How much data, like for example, by the way, can you recall what is the, if for example, all the bits are turned on, what is the maximum value? Or you can say, what will the value if all the 8 bits of a byte are turned on? Very quick. Quick, very nice, very nice. That's great, Ali. It's going to be 255. So if I talk about, if I'm working on an unsigned value, it means that the capacity or the data that can be stored is 255 maximum. Okay, but the moment I am talking about two's complement, then definitely the MSB, I'm using the term MSB. It could be any, it could be this one. If for example, you're working on a nibble, then definitely that will be different. That's why this MSB will now be holding a 1 or a 0, and this 1 or 0 will be indicating 1 means a negative number and 0 means a positive number. Okay, are we ready? Okay. Before we actually go with the concept of two's complement, let's see actually in which scenarios are we using a computer for storing the negative numbers. Like for example, you may have seen that whenever I'm using the banking apps, whenever we pay to someone or we actually use it for any sort of payment, then the app is going to deduct or subtract the money from my account. And definitely this is a subtraction process. Programs that are monitoring the temperature on board the space station, then that is also something that is dealing with the handling of the negative values. And a program that is calculating the miles left until the fuel is needed. So there are different situations which you come across that are dealing with the negative values. So you have to be very cautious that how will you handle them. Now, before we actually perform the working through 2's complement, let's see. If I say 16 minus 6, that makes 10. Simple subtraction, isn't it? We have been doing it since our childhood, yeah, that one number subtracted from the other, then it is going to give you the answer by subtracting the value. By the way, if I say this, do you agree that they both are same? In the first one, I'm actually performing the subtraction process. My bigger number is 16 and I'm performing the subtraction process and I'm saying minus 6. That gives me the value of 10. Perfect. But can I actually say that 16 plus and within brackets I say minus 6? Will it still give me the same result? Yes. It means that actually these both are treated as similar in nature, although you can see one more symbol is being used here, but they are giving you the same answer. So this is something that we need to see. Adding a negative number is the same as subtracting the positive number. So it's actually the same process. So in the first example, 16 and 6, they both are the positive values and we are subtracting them. On the contrary, if you talk about the second example, the 16 is a positive number, while 6 is actually a negative number, and I'm adding the two sums, and that is again giving me the same answer. By the way, I hope that you're not can say I'm not actually taking you back to math, but this is something that we need to understand because the same thing happens in everywhere. Like you talk about any situation, we are getting the same. So that is why we need to have this whole thing. I hope that that will help you a lot. Okay. Inshallah. Now, first example that we are doing is, I was asked to store the value minus 120. By the way, before I proceed to the discussion, what is the range of data? Like we talked about that in a byte, the data that can be stored is 0 to 255. Minimum is 0 and maximum is 255. And that makes total 256. Correct, Asim, for actually inputting this value. But if say, thank you very much once again, Ali, for pinpointing the same thing, that in a byte the minimum value is a 0, because if all the 8 bits are turned zeros, it means that the minimum value that can be stored is 0. And the maximum value means all the 8 bits are turned on. And as we discussed right now, this will give me the value of 255. Perfect. But in case I am talking about this byte, this MSB, as you can see, is now no more holding 128. It's now turned to minus 128. By the way, I said right now that minus this MSB is now holding a 1 to indicate it's a negative number, a 0 to indicate it's a positive number. So what is going to be the minimum value and the maximum value? The minimum value definitely will be a negative value, and the maximum value will definitely be a positive value. So what do you think will be the value here? Think about it. I just said this minus 128 will be holding a 1. And as we talk about, okay, let me give you a hint. As we talk about right now, zeros, minimum. It means 64, 32, 16, 8, 4, 2, and 1. The remaining 7 bits are all holding a 0. It means minimum value is going to be minus 128. Correct. Yeah, that's great. And what is the maximum value? Maximum value means a positive value. And what did I say? Positive value means 0 in minus 128 and all the other 7 bits are turned on. So if all the 7 bits are turned on, it means that the value will be Wonderful, Ali. It will be 127. So it means that the moment we talk about signed value, it means it can hold the value from minus 128 to 127. Clear? That's wonderful. Just as a sort of a, I can say, a sort of an exercise given to you so that you can comprehend the value, the minimum value, and the maximum value. Now, you can see the MSB is now minus 128. It is no more 128. And think about it. Which values will be turned on and or added to give you minus 120? If I say minus 128 plus 8 is going to give you the value of minus 120. Agreed? Because MSB is now no more storing the data. It's now storing the value indicating a negative sign, a 1, that means it is minus 128. And the rest of the bits are turned off except for the value that is indicated by 8. And when you talk about minus 128 plus 8, that gives you the value of minus 120. Agreed? Clear? That's wonderful. And now what we are learning is the actual 2's complement method. And this method is actually involving a three-step process. A very simple thing. If you actually remember the stages, you'll be getting the answer, accurate answer in a very short span of time also. And it is going to do the same thing. But remember, please, okay, now we are doing the same, minus 120. And now we are doing with the help of the 2's complement method. And what is it? First stage is you're going to actually ignore the minus sign completely, and you will actually find out the binary for the value 120. Okay, so what I'm doing is I'm finding out the binary for 120, which bits turned on to give. Now, please remember, first stage is ignore the minus sign, assume there is no minus sign right now, and you will actually find out the binary for 120. Okay, and you can see for yourself, 64 plus 32. By the way, just giving you a hint, 64 plus 32 results in 96. So just for a shortcut, in this manner, you will be able to remember. And then 16 and 8, they are turned on and they are giving me the result as 120. You can see for yourself, it's resulting as 120. 64 plus 32 plus 16 plus 8 is 120. Step number 2, you're going to flip the bits. It means all the ones will become zeros and all the zeros will become a 1. I think a very simple thing. You are going to, like for example, you can see 0 became a 1, 64 was a 1, it became a 0, 32 was a 1, it became a 0, 16 and 8 were 1s, they also became zeros, and 4 to 1 were zeros, they have become 1. So after I've taken the binary, I found the binary for the number, I have flipped the values, I have inverted them. All ones became zeros and all zeros became 1. Okay. Step number 3, I'm going to add 1 to flip binary, and you can see for yourself, it's the same addition process that you have learned. So you can recall that also. So now I'm going to start from the LSB right-hand side. 1 plus 1 will be 0 with a carry of 1. Now I have 1 plus 1, again 0 with a carry of 1. Now again 1 plus 1, 0 with a carry of 1. 1 plus 0, 1. 0 will come as it is, 0 will come as it is, 0 will come as it is, and 1 will come as it is. So I guess you can see for yourself that this is how, a very simple thing. I'm repeating, ignore the minus sign and find out the binary of the number. Then flip the bits, means all ones became 0 and all zeros became 1. And then add 1 to the flip bits and simple addition process applied. And what you obtain is the answer for minus 120. And this is the method that we apply for 2's complement. And it's for the negative numbers. Okay, I'll give you this thing also, that how will you. Now, isn't it similar to what we have computed earlier? But remember, please, when you're asked to talk about the positive number, okay, now if you're asked to talk about two's complement, you'll follow exactly the same way as we have learned right now, the 3 stages, and you will be getting the answer correct. Although you can use the prior method for checking your answers, but this is the method that you will actually employ to find out the two's complementing. Easy? Yes, that's great. Now it's your turn, and you are going to work to find out the value for minus 124. And you are going to use two's complement method. Okay, your time starts now. Let's see whether how many of you are able to get the right answer. Once your time starts now, please. Remember, minus 128 and the rest of the 7 bits are the same. Okay, you can do the work with both the methods. The first method that we did, that is also possible right now, but you have to do it with the two's complement also, just to see for yourself that whether your answers are matching or not. Is it done? Okay, that's wonderful. Now see for yourself, the MSB is minus 128 should be turned 1 because the number is a negative number. Now, if you're about what should be added to minus 128 to get the answer of minus 94. So you can see for yourself, if I turn on 32 and 2, so that will give me the answer of minus 94. Clear? Isn't it simple? Now let's do it with the other method. We are doing it by finding out the value for 94. Then we are going to flip the bits. We are going to add 1. See the same. On left-hand side, we have done the method that we have actually learned. And now we are applying the other two's complement method by finding out the binary for 94. You can see for yourself 64, 16, 8, 4, and 2 add up to give you the value of 94. And then, yes, clear? And then we are going to flip the bits. We're going to add 1. 1 plus 1, 0 with a carry of 1. 0 plus 1 is 1, 0, 0, 0, 1, 0, 1. So isn't the answer similar to what we have found on the left-hand side? It's also 1, 0, 1, 0, 0, 0, 1, 0. And this one that you can see by using the two's complement is exactly same. How many of us have got the right answer? How many of us are able to comprehend this? That's great. Okay, now, thank you, Ali, for asking this question. Definitely, since my concentration was only towards handling the negative numbers, that's why I didn't touch the positive aspect till now. But thanks for raising this question. Remember, very simple thing. Whenever you get a positive number, for example, assume that the number was plus 120. So the thing that you were supposed to find the value of, and the mentioned name was two's complement, you will simply find out the binary of the normal number. Like you will just do it the way you have been doing since the beginning, that converting a ternary number to a binary number. And that is your storing the data, storing your values into complement for the positive integers. Please remember, in the negative integers, the method changes a bit. For all positive numbers, the method remains exactly same. So you don't have to actually worry at all. Sometimes they may trick you. Sometimes they may give such questions that are a little bit tricky. But please remember that whenever you get a question that deals with this, you have to include, and you have to just perform it the way you have been doing till now. No change in your working. Clearly, everyone? Okay, thank you very much. Now, this is my question. Let's see another example. You are asked to store the value number -1. Now, another activity for you to comprehend how to work with 2's complement. And here the number is -1. Let's verify our answers. -128 plus 64 plus 32 plus 16 plus 8 plus 2 plus 1. And if you remember, we have talked about it right now. It's basically -128 plus 127, and that is your equal to -1. Simple. Now we are going to do it with the other method. First of all, I'll find out the binary for 1, normal. The LSB is turned on and all the others are off. We're going to flip the bits. All zeros became 1 and the 1 became a 0. Adding 1 to it, and what you get is all the values are a 1. Aren't the answers matching? Yes. So I hope that it's very simple, understood by everyone. Again, I'm repeating, for the positive numbers, you are going to use the same method as you have learned till now. And the moment you get a negative number, remember the 3 stages: finding out the binary for the normal number, flipping the bits, and adding 1. You will get the answer, and that is your work. Now, this is your one more question. Now, you are given a value, and you are asked to find out the equivalent Denry number. What will you do? Simple. You will put them in the right order. 1 1 0 0 1 1 0 1. You have placed them in the right positions, and you will simply add the way you have been doing. But the only change is your MSB will not be anymore 128. It will be -128. So -128 plus 64 plus 8 plus 4 plus 1. -120 plus 77. And your answer is -51. So if you are given question in this manner, see, one question is you are given a number and you are asked to find out the equivalent binary value. Perfect. But in some situations, you can be given a negative number and you are asked to find out the equivalent Denry value. So what you will be doing is simply you'll be adding up, and you will be just remembering that 128 will be treated as -128. Clear? Okay, now, thank you very much for being a part of this learning, this journey. Jazakallah khairan kasira. If you have really liked my videos, and share it, keep on sharing it with your friends and family. And please do watch all the videos that I've mentioned for reference, like addition of binary, conversions, etc. And share it with your friends and family. And please click on the bell icon so that you can subscribe to my channel. Click on the bell icon so you are able to get the updates of the videos as soon as they're uploaded. Jazakallah khairan kasira. Take care of yourself. Allah Hafiz.